Good evening, sir.
Yeah, good evening. Can you hear me?
Yeah, good evening, students. Good evening, sir.
Hello.
Yes, sir. Sir,
Can you
can
hear
you
me?
kindly start the session? Hello. I'm audible, sir. Hello.
Okay, shall I start?
Yeah, please start the session.
Hello. Hello. How to set up the problem in a much more refined and accurate manner. So that is how we actually proceeded with the things as per yesterday's lecture. We actually did the mesh conversion study. We did certain analysis related to the accuracy of the results. We had a lot of understandings related to that. We particularly had a proper channelized way of approaching towards the problem, starting from, yeah, please say, did anyone say something? Okay, so yeah, so in that scenario, I would today, uh, then I would like to help you understand the basics of the autonomous vehicle today. The core concepts involved into it by sharing the PPT relatable informations into it. And once that is done, we will probably do the rest of the things related to the propulsion unit because the autonomous vehicle is majorly contributed towards the complete automation of the compute system. So propulsion and its analysis plays a very vital role into it. So we will do an analysis of the propeller in the coming classes, wherein we will particularly do the channelized way of approaching towards the problem in a propulsion unit. So we'll take a propeller, we will do the analysis, computing the thrust and the torque of the propeller. And the reason why we are doing it is because you see the in the autonomous vehicle, the major chunk of work or task is related to the selection of the proper propeller in selection of the proper motor based on the certain designated torque and thrust, which are the requirements of the complete system. So, considering that into notice, we will probably do the analysis in such a manner so that we can evaluate the amount of or compute the amount of thrust and torque by the propeller, in turn selecting the motor which is required for the proper analysis or proper working functionality of the uh, ground autonomous vehicle. So, or then we will do a parallel analysis of the same in the aerial autonomous vehicle also. So there also this complete section of selection of the uh, propeller is needed in such a manner so that the uh, uh, motor selection becomes accurate. So motor selection will become accurate only when one will have a proper understanding of the um, complete system. And complete systems understanding is done by doing an analysis in ANSYS fluent and getting an idea or the ballpark value of the amount of thrust and torque. So this amount of thrust and torque will be recorded, and the recorded thrust and torque will be finally measured and computed through ANSYS. So that is what we will be doing in the coming class. But today we will be doing a few selecting of a few PPTs which are related to the autonomous vehicle. So, so let me bring those PPTs. So first is this PPT. So I hope my screen is visible. Can you uh, please confirm? Uh, the XLR team, can you please confirm my screen is visible or not?
Yeah, yes, sir. Your screen is visible.
Okay, okay. So now, before starting the complete session on this autonomous vehicle, uh, so what we have discussed and actually learned in the past from the electric vehicle, electric autonomous vehicle, and its analysis comes to a very crux note because now we have an understanding and a clear-cut knowledge about the electric vehicles. What are its significance? So, electric vehicles and ground autonomous vehicle both work in the same similar fashion. So, there is not much of a difference. Only the electric vehicle and autonomous vehicle, the major difference is the automation. So, uh, majorly driverless cars are basically the autonomous vehicles, but autonomous vehicles are also electric vehicles. So, electric vehicle, autonomous vehicle is a subset of electric vehicle. So, when we are covering the electric vehicle, we have been covering the autonomous vehicle indirectly or directly. So, when we did the analysis of the electric vehicle and when we did the CFD simulation of the electric vehicle to compute the performance, we majorly did the analysis of the autonomous vehicle as well. So, whatever we did in the autonomous vehicle is actually resembling to our understanding that we have been doing the analysis of the autonomous vehicle and the electric vehicle in the similar fashion. So, setting up the problem. So, in the autonomous vehicle, also there are two types of autonomous vehicle. The first one is the ground autonomous vehicle, that is the electric vehicle, electric ground electrical GEV that we have been discussing from the past 7, 8 classes. And the second one is the aerial electric vehicle or aerial autonomous vehicle, so AAV. So one is GAV and one is AAV. So in the GAV section, the ground autonomous vehicle, the understanding remains similar. So whatever we did in the area ground autonomous vehicle is actually the similar thing that we did in the analysis. Just a minute. So whatever analysis we did in the aerial autonomous vehicle, sorry, ground autonomous vehicle, is a similar one. That, so I'll drive you through one of the example problems in aerial autonomous ground autonomous vehicle also, and then thereafter we will do three major analysis problem in the autonomous vehicle section also. The first one will be the selection of the propulsion unit, that is the selection of the motors and the selection of the by doing an analysis of the propeller, we'll be computing the required thrust and torque. So we'll be targeting a certain amount of thrust, and for that thrust, we'll be computing the torque of the propeller. And then after computing the torque, we will be actually having an understanding that what is the uh, criteria of selection of the propeller. So we'll select the propeller accordingly, and once that propeller is being selected, uh, we will actually in turn have an understanding about the accuracy of our selection based on certain understandings and certain principles. And maybe we'll do it or cover it in the next class, or else we'll start from today only after completing two sections of PPT. Maybe we can start it today, and then in the next class we will majorly and from after that we will next class also that will only run up, and after that we will be doing two example problems. One will be for the ground autonomous vehicle, uh, again computing its performance analysis fluent, and then another one will be analysis of the aerial autonomous vehicle. So aerial autonomous vehicle is a different thing. So I guess, and I am sure that people who are joining this class have heard about drones. So drones are nothing but a, a sub criteria of aerial autonomous vehicle. So autonomous vehicle, nothing. It means that it is driverless, and it operates totally based on algorithms and autopilot. So you program the autopilot, and when you program the autopilot and send it for further mission analysis, the complete mission is getting carried out by that principle only. So the aerial autonomous vehicle is nothing but that only. Uh, and drones are a subcategory of aerial autonomous vehicle wherein you actually, so drones are also of different types. So drones are nothing but there are different types of drones. First one is the uh, so, for example, if I'll tell you, the first one that you see, the type of drone is the quadcopter. So, quadcopter is a sense of drone which is having four propellers and it hovers. It hovers means it hovers to a point, uh, and then it goes here and there. So uh, it moves from point A to point B using propellers. So it do not have wings to move. So it uses propeller. It pitches to a certain extent and then it moves forward. So it is nothing but a propeller-based autonomous vehicle. So its speed is slower, and the endurance is lesser in the case of uh, quadcopters. Then there comes, so quadcopters means four rotors, hexacopters means six rotors, octacopters means eight rotors. So and then comes the fixed wing. So fixed wing means it has a propulsion unit to match the drag, but it majorly has a, so just give me a moment, I'll show you. So So if you see, you see the screen XLR concerned person, can you please help me with that? You can see the screen, right?
Yeah, yes, sir. Your screen is visible.
Okay. So the first criteria. is the quadcopter. Quadcopter. The second criteria is the fixed wing. The third criteria is the biplane. And fourth is helicopter. Helicopter. So here there are four rotors. If they have four rotors, it is called quadcopter. If it has six rotors, then it is called hexacopter. And if it has eight rotors, it is called octocopter. Okay, so that is the category for this. Now comes the fixed wing. So fixed wing is nothing but if you see like this, all the passenger aircrafts that we have, they are fixed wing. So it has a wing, it has a wing. So now, so yeah, now comes complete session. So herein is what I wanted to tell you guys that this complete understanding is needed for the proper uh, the autonomous vehicle. That there are two kinds of autonomous vehicle. First one is the ground autonomous vehicle, and second one is the aerial autonomous vehicle. So ground autonomous vehicle is nothing but which runs on the ground. An electric vehicle is major case point of the autonomous vehicle. And autonomous vehicles are also majorly electric vehicles. So yeah, the aerial autonomous vehicle are nothing but the drones, larger drones and smaller drones. The drones are further divided into various subcategories like fixed wing, biplane, uh, and monowing, tri-wing, and tandem wing helicopters. So these are the cases. So now comes now we will be taking into consideration the PPT part. So what is the autonomous vehicle introduction and its fundamentals? So we'll be discussing the definition, the SAE levels of protocol, history and motivation, and applications and its benefits. So these are the things that will be. The first point that will be in here is the workshop agenda. So what is the agenda? So this complete session will be around 2 hours session to explore the foundational concepts and technologies powering autonomous vehicles. We will journey through definitions, evolution, standardized levels of autonomy, and the transformative potential of self-driving technology. So the definition and the core concepts are including the understanding of autonomous vehicles and their fundamental and their fundamental definition, understanding the autonomous vehicles and their fundamentals components. So this comes under the definition and core concepts. The second one is the evolution in autonomous automation. So journey from manual driving to full autonomy. So when you remember journey or the case study of Tesla, so Tesla actually started from a uh, driver based uh, automobile, but uh, slowly and steadily, what happened was the complete autonomy did not got attained in a single go. Slowly and steadily, Tesla moves from driver-based automobile to semi-autonomous vehicle, wherein you have the capability of driving the uh, car on certain areas in an autopilot mode. So, for example, if you go on a highway, therein you get a chance that you can put your complete system on automation, and then you can fix the path between A to B in the map, and was the Tesla. I was telling the story about Tesla. So it slowly and steadily moved from a driver-based to semi-automatic based, and then from semi-automatic it moved to just a minute. Give me 2 minutes. Just give me 2 minutes. I hope I'm audible. Uh, yeah, can you please
Yeah,
confirm?
yes, sir, you are audible.
Okay, okay. Yeah, so the major, what I was telling was the story of Tesla. So slowly it moved towards semi-autonomous automation side. And then thereafter, after further refinement and technological developments into the same, the system moved towards a full autonomy. So in the full autonomy, what happened was the system or the car, the people worked hard for that. And then today, when we see the complete system is of Tesla automobile is designed in such a manner that you be from any place in US or any place, you feed in from point A to point B, and then your car can fix its mission accordingly, and then it can move from point A to point B despite or the traffic or everything. So it has the capability to stop in the traffic when the traffic is more, and accordingly react to it. So it is very nice now. So yeah, it comes with time and effort. Slowly, you can't get everything in a single go. Slowly and steadily, you have to work onto it. And then once the thing is set, process is developed, then you can actually leverage onto the complete system. So that is how I wanted to say. So now the third point is SAE levels from 0 to 5. So we'll be discussing the detailed exploration of standardized automation levels. So I told you the complete journey for Tesla. Similarly, we'll be discussing the SAE levels from 0 to 5, 0 being the minimum, 5 being the maximum, how we are going to approach towards the problem and build a uh, uh, non-autonomy to a semi-autonomy to a full autonomy. So that is how your automation is happening and your autonomous vehicles are designed. Now we'll be discussing the history and the motivation, wherein we'll be discussing the key milestones and drivers behind autonomous technology. Then we'll be discussing the applications and benefits, where real world use cases and societal impact is discussed. So now comes the learning outcomes. So what are the learning outcomes that we'll be going to discuss? So by the completion of this session, participants will have had a comprehensive understanding of autonomous vehicles, fundamentals, and their real world implications. So, we'll be discussing the definition of autonomous vehicles by articulating core concepts, key terminologies, and fundamental principles that underpin self driving technology. So, that is how, so this means that we'll be completely focusing on the key core concepts, which will be defining the technology and fundamental principles that are lying within the self-driving technology. The second point that we'll be discussing is tracing the technology evolution. So in this section, we'll be describing the critical milestones in these progression from driver assistance to full vehicle automation. So that is how we'll be taking this forward, wherein we'll be discussing the critical milestones in the progression and driver assistance to full automation. That is what I told, right? So initially, driver was needed for complete functionality of the automobile. Then semi-driverless car came, wherein you can put on auto pilot over the this thing over the highways, and then comes the full autonomy. So that is how things are done. Now, it's now comes the explanation of SAE levels. So distinguishing between SAE levels from 0 to 5 with practical examples and understanding their technical implications. So that is very important. Now identifying and identify the motivation. So by articulating historical context, so how the history in the history people have worked upon these concepts hard, and then thereafter they developed from the very scratch to the autonomous vehicles. So by articulating context, societal drivers, and key stakeholders propelling autonomous vehicle development. Now assess the applications. So evaluating principal use cases, benefits, and transformative potential across transportation sectors. So now we'll be discussing what is an autonomous vehicle. So uh, to give you an example of it, I actually discussed about Tesla. So autonomous vehicle is nothing but a driverless vehicle or a semi-driverless vehicle which can function on commands and programming without the physical involvement of the driver, so that the driver can feed the map locations with the autopilot being such intelligent that it can take the vehicle from point A to point B without the prior involvement of the driver in the complete journey. So now we'll be discussing the definition of it. So an autonomous vehicle is a sophisticated system capable of sensing its environment and operating without human intervention to perform all driving tasks safely and efficiently. So that is what I told, that an autonomous vehicle is a system that is capable of doing all the things taking from point A to B without the prior intervention of the driver. So this is actually coming with safety and efficiency as well. So it doesn't mean that you take the person from point A to point B. It is very important to take the person from point A to point B, but with an understanding that the safety and efficiency is kept into consideration. It shouldn't happen that the autonomous vehicle takes the person from point A to point B so fastly that it risks the health and life of the person sitting inside it. Or else it shouldn't go so slowly that a person can walk and reach from point A to point B faster than what the autonomous vehicle is doing. So it should work on an optimum intelligence level so that it can function properly and efficiently moving from point A to point B with a proper without having proper human intervention. Now comes the key elements. What are the key elements? So perception, perception, decision making, actuation, and connectivity. So what are these actually meaning? So perception means understanding the surrounding environment through sensor data processing. So that is true that perception is actually meaning the understanding of the sensor data that is getting processed throughout. The second point is the decision making, which means the first point is perception, which is understanding the surrounding environment through sensor data processing. Second point is the decision making, which means intelligent planning and reasoning about optimal driving actions. Third point is actuation, precise control of steering, acceleration, and braking systems. So that is true. In this case, we will be discussing that. So actuation. So what are the components that require actuation? So actuation are basically required by the accelerometers, the steering, and the braking system. So the steering and the braking systems are also controlled by the servos, and that complete servo is going through a autopilot control key algorithm process wherein autopilot gives command to move the steering to such a rotation and move the brake to such a rotation and move the accelerate the complete accelerator to such a location so that the complete efficiency of the um, autonomous vehicle gets restored and maintained. Fourth point is the connectivity, communication with infrastructure, other vehicles and closed services. So that is very important, right? Because when you are driving the vehicle on an autonomous or autopilot mode, the communication becomes very key. So if the communication between the uh, autopilot and the vehicle doesn't happen properly, then you won't be getting. So there are different types of sensors also, like lidar, radar, and everything, which actually captures the proximity. So when your vehicle is moving on the road, there are other vehicles also that are moving on the road, and they might not be intelligent and completely autonomous. So, and they could be autonomous also. So the communication of the autopilot should be in such a manner so that your complete system should be having a feedback loop mechanism to get the understanding of whatever is happening in the surrounding and then thereafter reacting according to it and making a key decision. So it should be intelligent enough to make key decisions to choose the path in accordance to the motion of the vehicle in a efficient manner. So that is very much important that your complete system should work in such a manner so that your system should be observing and behaving in a recursive and a pattern-based manner to completely formulate and uh, move the vehicle without any accident or intervention. So that is the case. Just a minute. Yeah, so. Now, these are the 4 points that we discussed. So, perception, decision making, actuation, and connectivity. I hope people understood these. So, now in the actuation, there are sensors that we were discussing. So, sensors are basically for data collection, and data collection is very much important for a proper feedback loop mechanism. Because if data is not collected properly and the communication of the data point with the complete sensor mechanism doesn't happen in a regular phase, then your vehicle shouldn't be very much efficient in moving on the road in an autonomous mode. Then comes the perception, so environmental understanding. So environment understanding is so nowadays, uh, I hope I don't know if you guys have heard about GPS denied navigation. So have has anybody heard about GPS denied navigation? Can you please drop it in the chat if yes or no? I'll wait for 2 minutes. Can you please tell me about GPS denied navigation on the chat? Has anybody heard about it? Yes or no? Yeah, GPS denied navigation. So not GPS navigation, but GPS denied navigation. Have you heard about it? I'll tell you what is it. So GPS denied navigation is nothing but when you have a map and your magnetic compass in that map is working and your GPS or radar sensing is operating properly, then you can go from point A to point B in a very good fashion. Don't worry, I'm explaining it. No problem. Thank you. So, uh, when you have a magnetic sensor or a GPS um, for assisting the directions and protocols moving from point A to point B, then going from point A to point B becomes very easy. But in GPS denied navigation, you have a mapping mechanism for environment using the perception based code, wherein you map the entire area prior so that when your GPS is denied in that area, you have that map stored within your algorithm so that you can move from point A to point B without the help of GPS in a proper manner, without any failure. So that is a very important technique that is being used in the CICT operations in which the army does or any counter-terrorist body does to actually compensate or neutralize the area without even having a GPS-based algorithm. So without a GPS-based algorithm also, they are very much capable of actually uh, because there are certain jammers that are being placed in such areas. So you cannot actually always work into that areas without with the GPS. So there are certain conditions wherein your GPS doesn't function. So in that scenarios, you have the capability within you to actually function without the GPS, mapping the complete area prior and then completing the mission. So that is the perception thing. I hope it is clear now, uh, Rishi. It is clear, right? whatever I told, it made you understood, right? Okay. Hmm. Now comes the autonomy versus driver assistance. So in that complete comparison, in the autonomy versus driver assistance, we'll be discussing. So yeah, this is what I was telling you, that the driver assistance and complete driver functionality are two different things. So driver assistance means driver has to be present into the driving seat to observe that everything is working properly or not. And driver based thing is the driver only has to operate moving from point A to point B. But driver assistance means there are automation involved into it, and there are GPS based there are autopilots involved into it, which can take the vehicle from point A to point B. But there is an involvement of the driver to actually mitigate the complete process for accuracy. But in the case of autonomy, uh, full autonomy means your complete perception is being taken into consideration, and full planning is being done by the autopilot, and no human input is being needed, and safety assurance is not getting hampered due to it. So everything happens in hand, and nothing gets affected due to a full autonomy. So now we'll be discussing that in detail. So autonomy versus driver systems. So understanding the critical distinction between systems that assist drivers and those that replace them entirely is fundamental to grasping the autonomous vehicles landscape. So first one is the driver assistance, ADAS, the adaptive cruise control. That is, the cruise control is being independent and it makes a safer distance. So I'll tell you what is adaptive cruise control. So actually what happens here is the complete thing functions on the autopilot, that is sure. But your cruise control maximum or minimum value is being set by the driver. And after setting up that value, the functionality of the autopilot is that it can switch between the maximum and the minimum limit according to the need. So the need you don't need to specify. That the autopilot will decide on its own. But the minimum and maximum value will be decided by the driver. So driver assistance is required in such a manner. But in the full autonomy, the minimum and maximum is not required to be concerned within the system. It will take care by itself. Yeah. The second is lane keep assist. So what is lane keep assist? So yeah, that's what I told you, that in a highway where only you want to move your vehicle on a single lane and you do not require to shift the lanes in between. That time, a driver assistance or a semi-autonomous vehicle will also work on the autopilot. But when the lane change comes into picture, that time actually driver assistance is required. So the driver actually helps in maintaining the lane position. So the lane position is getting maintained by the driver in that case. And the third point is automatic emergency braking. So that is true. So in the emergency braking condition, if your vehicle is a semi-autonomous vehicle, so that time your driver needs to keep an eye on the situation very positively, so that when any time any hazardous situation comes into picture, the driver is completely capable of taking the control back to himself from the autonomous mode, shifting from the autonomous mode, and keeping the brakes intact so that the collision could be avoided. So that is automatic emergency braking that prevents collision. Automatic emergency braking prevents collisions. Okay. So now blind spot monitoring. So alerts to vehicles in blind spot. So blind spot monitoring is also a very key feature wherein you get a chance to actually observe the complete scenario in such a manner so that your driver has a complete eye on the blind spot, and there the driver can take control and move the vehicle accordingly. Next is the parking assistance. So parking assistance is also a very important and a prominent thing wherein you get a chance to actually move the vehicle in such a manner or such a fashion wherein you aid the maneuvering into spaces with proper driver control. So driver remains responsible and must monitor at all times. So the key underlying note for this complete system is that the driver should remain responsible for each and every situation and must monitor at all the time. So it shouldn't happen that the driver becomes very uh, okay and doesn't keep attention and uh, cannot he cannot be lethargic and he cannot be negligent about things. So he has to keep an eye on everything that is happening around. Okay. Now comes the full autonomy. So in the full autonomy section, the complete perception, that is 360-degree environmental awareness is needed. Now full planning. So end-to-end route and maneuver decisions is also needed. Total control. So all driving tasks are automated here. No human input. So system operates independently. Safety assurance. So handles all edge cases and scenarios. System is entirely responsible. Driver becomes a passenger. So now we'll also read this again to have understanding in a thorough manner. So, yeah, now let us see. So, full autonomy. What is full autonomy? Full autonomy is nothing but complete functionality is getting controlled by the autopilot. So, okay. So, autopilot is responsible for complete autonomy and functionality control of the entire system without any human intervention uh, into it. So, complete perception. So, 360-degree environmental awareness is getting maintained by a complete 360-degree eye view. So I told you that mapping happens automatically and accurately in such a manner that other people are not required to actually get involved into it. So that is very much taken care of by the same. The second one is the full planning. So end-to-end route and maneuver decisions are also getting taken by the autopilot. So that is not required every time and each and every time that your route and maneuver decisions should be taken up by the driver. So every time you move it from point A to point B, your complete system is capable enough to take the decisions in such a manner that motion happens from point A to point B with accuracy. It doesn't happen that the motion is getting restricted by any source of driver input. It happens by accuracy. Now, third point is the total control. So all driving tasks are automated. That's what I told. That now in Tesla also everything is getting automated and everything from point A to point B, whether you move from point A to point B in any fashion, it takes the most optimum path route and helps you reach to point B in a best possible way. So you don't need to worry about anything in prior. Everything happens with a full autonomy. Third point is the total control. So all driving tasks are automated. So that we told. So no human input. So system operates independently. So here, there is no human input. So the system operation actually happens totally by the autopilot. So there is no need or no requirement whatsoever of the human input. So the human is actually becoming like a passenger. He doesn't have to worry about any sort of driver related control issues. Everything is getting taken care and controlled by the autopilot. So that's what. Now comes the safety assurance. So handles all edge cases and scenarios. So, for example, I told you, right? So when you, for example, when you consider this car, consider this as the edge cases. Okay, so these are the corner points. Suppose these are the corner points. You want to move from point A to point B, and this is your car. So it's moving. Supposedly, it takes another turn. It takes another turn, and it faces this. So it has the capability to move here, come back, and reach point B. It takes care of all the edge cases. So supposedly it moves from point A to point B, and point C drop is here. Point C drop is here. Okay, and there is a collision avoidance at this place. So it takes care of this point very well, and it doesn't require a driver intervention, and it drops at point C, then comes back here and reaches point B. It doesn't have to worry that the driver needs to take a control and move from this edge case to. It takes care of the edge cases very well, so that is not a problem. Okay. Now comes the uh, yeah. So system is entirely responsible. Driver becomes a passenger. That is true. Now the key technologies powering autonomy. Okay. So autonomous vehicles integrate multiple sophisticated technologies that work in concert to perceive, understand, and navigate complex driving environments safely. That is true. So, what are the key technologies powering autonomy? Uh, I wanted to say that whenever a technology becomes so much popular, or whenever technology becomes so much familiar to everyone, the understanding or the acceptance that people has only comes after the reliability of that product becomes more and more. So whenever you go into a shop to buy certain things also, you always take care of the branded stuff. So you always buy branded stuff, not because only because of the quality, because you are trusting that brand so much that the quality of that complete product will be nice only. So that is a very important thing to win the environmental market, and trusting the complete system is very important. So if you don't actually have that trust building capability into action, that becomes a hectic problem or a hectic task to actually mitigate the entire situation. So autonomous vehicles integrate uh, multiple sophisticated technologies. So multiple sophisticated technologies, LiDAR, sensors, automation, GPS navigation, perception, uh, different types of driverless techniques, accelerometers, uh, uh, automated steering wheels, automated brakes. Everything is a sophisticated technology in itself. So all these sophisticated technologies are brought together, and uh, multiple sophisticated technologies that work in concert to perceive. So it works in tandem, it works in a systematic manner to perceive, understand, and navigate complex driving environments safely. So when we move from point A to point B in a highway, it is very simple. But when we move in certain one-way routes, uh, or two-way routes, wherein you have a crowd around you, that time it becomes very much difficult, and your autopilot needs to be very intelligent and very cautious in actually making decisions. Otherwise, yeah, problems could occur. So yeah, sensors. So sensors include camera, LiDAR, radar, and ultrasonic systems capture comprehensive environment data. So what is a camera? Camera, you know everything about camera. So it actually captures the image processing for the processing purpose. Now LiDAR. LiDAR is basically a proximity sensor. So supposedly I'll tell you. Your car is moving from this place to this place. Okay. Now you have a pole here. So it will send signal, and that signal will reflect back to its receiver. Okay. It will receive, and then it will go towards that feedback loop mechanism. Feedback loop mechanism. That feedback loop mechanism will actually sense that what is the issue, and it will process it in its brain that this is an obstacle. So then it will by itself move here and then go to point B. Okay. So that is the functionality of a LiDAR. So a LiDAR is an obstacle avoidance sensor, which actually helps you to understand uh, the obstacles in its proximities to actually avoid the collision. Okay, now comes the radar. So radar, you know that it is actually to actually get the data of the mapping. Now ultrasonic system to get the heat wave capturing, heat signature capturing. Now also there are environmental sensors to actually comprehend the entire sensor procedures. Okay. Now comes the V2X connectivity. So vehicle to everything communication enhances situational awareness and coordination. So V2X connectivity is actually something like a Wi-Fi or something like a Bluetooth, which is actually capable of everything communicating to the vehicle that enhances situational awareness and coordination. So the situational awareness and coordination works very importantly, and they are very, very significant enough to actually function in a very critical situation in a automation or automated system environment. Because in an automated system environment, you need to keep an eye on everything that is happening around you because you can't take risks in between to actually move from point A to point B without having a proper connectivity. So this communication mechanism is actually helping you to get a situational awareness and know the conditions around you very accurately. Now comes the mapping and localization. So yeah, mapping and localization comes from radar. So this radar which you see here, this part, is actually helping in mapping and localization. So mapping and localization is actually helping you to get the location precisely and accurately. So even if you're working in a GPS generic navigation system configuration environment, you need to have that complete mapping with you to have an understanding about the motion from point A to point B with accuracy without any failure. Okay, so that is how your things should work like. Uh, now, now comes the Z maps and precise positioning that enable lane level navigation accuracy. So you said no that lane change is actually not possible in a semi-driving, semi-autonomous vehicle because lane change is actually happening through the involvement of a driver. So in this, the radar technology has to be very much accurate to get the GPS data accurately mapped enough so that your radar, uh, so that your lane change happens with accuracy. Okay. So that is how your mapping and localization is actually effective. Now comes with perception and ML. So machine learning and perception is actually so GPS denied navigation that I told you that complete system environment is getting created in such a manner that your system will be accurate enough to map the entire data without a GPS and then complete the mission from point A to point B without a GPS because it has prior data embedded into it which it uses at that time to help you navigate through the situation. So machine learning models detect, classify, and understand dynamic objects and scenarios. So not only reaching from point A to point B is important, it has LiDARs and everything embedded into it so that while moving from point A to point B in a GPS denied navigation, because if you are working on GPS denied navigation without radars and everything and GPS, without radars and GPS and everything, then that point in time you won't be getting the dynamic uh, information about whatever is moving onto that path. So your LiDAR sensor needs to be very much accurate enough to actually capture the entire things physically on a live manner and then take the decision based on that. So that is very much important. Okay. Now comes the planning and control. So planning and control also becomes very important because planning and control actually only helps you to take the decisions in a wiser manner when you want to move from point A to point B. So intelligent algorithms determine optimal paths and execute precise vehicle movements. So precise vehicle movements is done nothing uh, but only by a proper intelligent algorithm that is helping you to determine the optimal path and execute proper, precise vehicle movements. So these becomes a key technology powering the autonomy. So if you are working towards building a complete autonomous vehicle, so you want to take a look onto the sensors, you want to take a look onto the connectivity, you want to take a look onto the mapping and localization, you want to have an understanding and proper perceived knowledge about the perception and ML, machine learning. Also, the planning and control becomes very key because in this point in time, you are having certain passengers inside your car and you are working on a driverless mode. So your complete system should be very much intelligent enough to actually take decisions wisely so that no one inside the car is getting harmed due to. Okay. Now comes the sensor technologies, the eyes and ears. So, uh, yeah, the sensor technology. So, why they are called the eyes and the ears? Can anybody say why the sensor technologies are called the eyes and the ears? Can anybody say in the chat? Uh, I'm audible, right? Uh,
Yeah, yes, sir, you are audible.
okay. So, can anybody say why the sensor technology is called the eyes and the ears? Just on the chat, you can write. Yeah. Can you please say? I'm waiting for a minute for an answer. Why the sensor technology is called the eyes and the ears? Anybody? Nobody is interested to reply onto it. So I'll omit it. So yeah, sensor technologies are called the eyes and the ears. The eyes and the ears. So the main reason for that calling it to be the eye and the ear is that uh, it helps you in keeping a coordinated and controlled uh, observation onto the path that the automobile is following from point A to point B or anywhere. Because if you are working on a complete automated system environment, it becomes very difficult and very key. Uh, it becomes a very key parameter to actually evaluate uh, the fashion in which your complete system is getting operated. So if your uh, these sensors won't be operating in a very optimized manner, then it will lead to haphazardous situations. So these are very important for complete uh, observational understanding of the system. So that is why it is needed. So for a pure, clean brain check of the complete path, so that your accuracy of vision is getting restored and maintained. Okay, so that is the reason why this is being used and talked about so much, because this is a very important thing that needs to be checked. So yeah, that is the case. Now comes so sensor technology, the eyes and the ears, the eyes and ears. Sensor technologies, the eyes and ears. Autonomous vehicles rely on sensor fusion, combining data from multiple sensor types to create a robust, redundant perception system capable of operating in diverse conditions. So that is true that autonomous vehicles should rely on such sensor-driven technologies, which are actually the best available in the market, because these are the technologies that will be completely relied upon when moving from point A to point B in an accurate fashion. So yeah, this is very important to be understood that the sensor technologies plays a very vital role in the motion of the complete system from point A to point B, and nothing should be kept lagging onto it. So everything should be maintained in such a uh, proper and fused manner that everything combining the data together and keeping all the sensor type information intact, everything becomes accurate. So autonomous vehicles rely on sensor fusion, combining data from multiple sensor types to create a robust, multiple data types to create a robust, redundant perception system capable of operating in diverse conditions. That is true. Now, the first eye and ear of the autonomous vehicle is the camera. So, what is the significance of it? So, the camera is actually reference. So, rich visual details, color recognition, textures, signage reading, lane marking decisions. So, yeah, these are the important parameters that are being controlled by the camera. So, for example, the visual details are being provided with the camera. Color recognition is also provided with the camera. Texture of the road or the place or anything is being provided with the camera. Signage reading. So what is the signal uh, signal of the system at that time? That is also being provided by the camera. So these are the things that are these are the things that are provided by the camera. Signage reading and lane marking detection. So lane marking becomes a very key feature in complete understanding of the motion of the air referencing motion of the automobile, uh, because lane changing becomes a very minutely recorded and accurate detail, because if your lane change doesn't happen properly, other vehicles coming from the back can collide with you. So lane changing also becomes a very key. That is its strength. So camera strength is that. What are the limitations? So sensitive to lighting conditions, weather, and requires robust image processing. So robust image processing, large amount of data, large size of data are getting recorded here that needs to be captured and regulated properly. So that is something that needs to be formulated and regulated enough. quite accurate and continuous manner to actually keep an eye check on the system. Second is the LiDAR. Strength of the LiDAR is precise 3D geometry. Okay, so LiDAR strength is precise 3D geometry. So it helps you to actually make the complete. So I told you, right? So here I told you that it has a pole. So the LiDAR's this part receiver is this. This is the emitter. So it emits and then it bounces back and it creates an image in the background. So it creates the image of the same thing that is there, and based on that, its dimension and diameter, it takes a decision to move from a different path, right? So it takes a decision to move from a different path. So that is the case. So precise 3D geometry is getting made. Accurate range measurement, that's what I told. And excellent spatial resolution. So resolution is also being managed and maintained in a very accurate manner in the LiDARs. So what are the limitations? So higher cost affected by heavy rain or fog, complex data processing needs. So yeah, the size of the data is a very important entry level thing that needs to be managed here also. Also, it has a very high cost coming associated with it, affected by heavy rains and fog. धूल से भी होता है and after that complex data processing needs as well. बारिश और धूल से भी होगा heavy rain or fog. Then after that radar. So third is the radar. So in radar, what happens is direct velocity is there. Measure direct velocity measurement. So like the barometer does or any other pressure probe sensor does. So radar also happens to work on such fashion. Weather overs, long range detection capability. So long range detection. So these are long range. These are the other one camera and radar are short range ones. But radar is a long range detection capability sensor. What are its limitations? So limitation is lower resolution, difficulty with stationary object and classification. So yeah, that is true. That in the this criteria of radar, these are limited to resolution and they are limited to difficulty with stationary object classification. So mobile object is fine. For stationary object, it's a very much uh, non-informative thing into it. So these are the challenges of radar. Now comes the ultrasonic sensor. So the strength of the ultrasonic sensor is the strength is it is excellent close range detection, low cost, reliable for parking scenarios. Okay, so these are its. So ultrasonic is a ray, right? So how far the ray can travel, that is actually uh, dependent on the accuracy of the data and what it can provide. So the limitations are very short range, typically under 5 meters and low resolution. Okay, so yeah, this is there. So these are the things we matlab, the limitations are very short range, typically under 5 meters, and it has a lower resolution. So these are the four things that are majorly called the eye and the ear of the sensor technology in autonomous vehicle. First one is the camera, second one is the LiDAR, third one is the radar, and fourth one is the ultrasonic sensor. So these are the important parameters that needs to be considered and checked properly for a proper accurate system level modeling of the autonomous vehicle. Now perception and machine learning. So these are very key features or key concepts that are being uh, implemented that has to be implemented for accurate level modeling of complete a complete system. So yeah, what is Can anybody tell what is the perception in machine learning and how it is used? I have already discussed it earlier in the class, but can anybody tell that again? So, what do you understand by perception in machine learning and how it impacts? Anybody? Okay, so I'll only tell you. So, perception and machine learning. So, what are the core perception tasks? So, machine learning models serve as sophisticated pattern recognizers trained on vast datasets to interpret sensor data and understand complex driving scenarios. So, that is true. So, what are the core perception tasks? So, these machine learning models are actually very sophisticated and designed with proper, careful eye observation, which actually helps in pattern recognition. And they are trained over vast n number of data sets. So, they are trained and trained and trained over large data sets. So that because it works on permutation combination, right? So how much of data you actually feed into the system, it becomes the brain or the storage brain of the system, and based on that, it can take decisions. It doesn't take decision by its own. You have to train the model, and then from that training, it actually does permutation and combination. Similar happens with AI also, like ChatGPT. You train the model so much that you feed the data so much that it has access to n amount of data that you cannot restore within your brain at the active state. You have it in the passive state. You do not actively use that data very frequently. But the chat GPT doesn't have that kind of active and passive brain state. So what is fed into the system is actually in the active state. So that is the reason why we actually say that sometimes efficiency of the ChatGPT is more. I do not agree to it. If you can use your brain in a very efficient manner, I think that becomes a more efficient methodology because we are the one who have trained these ChatGPT models. So, but yeah, that is true that these models are being recognized and operated in such a fashion that it has active knowledge-based control into it, embedded into it, and it picks the data from there directly on displays. So that is why you train the model onto very large various data sets to interpret sensor data and understand complex driving scenarios. So complex driving scenarios are getting uh, managed and regulated by these formation. Now comes the object detection. So identifying and localizing vehicles, pedestrians, cyclists, and obstacle in 3D space. So, object detection is one of the key core underlying principles of perception and machine learning. It actually helps you in localizing vehicles, pedestrians, and cyclists, and obstacles in 3D space. Second is the classification. So, classification also becomes a key parameter wherein you have to determine the object types behaviors and predicting future trajectories. So actually, it becomes a very futuristic idea wherein you want to deal with the perception models in such a manner, in such a fashion that you actually have a predictive model approach wherein you have a point A and point B, and then based on point A and point B and its behavioral outcome response, you predict point C. So it is not a direct, uh, it can be wrong, it can be right, but it is a permutation based model. Most of the times, your behavioral aspects are getting observed into it, and your model actually replicates that and actually acts according to it. So it doesn't happen that it becomes unuseful or trivial. It becomes very selectively okay at times, and you have to be very selective to it. Semantic segmentation. Semantic segmentation. So pixel levels, understanding of drivable surfaces, lanes, and scene structure. So yeah, so actually your pixelated thing is actually getting observed and objectified here, wherein you actually a complete car is actually pixelated into different pixels, and then how accurate is your pixel and how good is your image quality processing. Based on that, it actually has a segmentation unit which actually understands the drivable surfaces, lanes, and scene structure. So these you see the lanes here, no? So these are actually segmented into different pixels, and then it gets back to the feedback loop, and then it takes a decision, and then it goes based on that acting according to it. So it is a complete back and forth model which actually works on the principle of these things only. And yeah, that is the case. I do not have the Google Form. I think XLR designated person will send that. So yeah. So can you hear me?
Yeah, yes, you are audible.
Okay, okay. So you'll be sending the attendance link, right?
Yeah, I'm sending it in some time.
Okay. So that is just semantic segmentation. The fourth point is the sensor fusion. So in the sensor fusion technique, actually it is integrating multimodal sensor data for robust and redundant perception. So this becomes very much important and informative because sensor fusion technique actually involves these things working in fusion and tandem that I told you very before also that it works in optimal way. So it integrates multiple sophisticated technologies and work together to perceive, understand, and navigate complex driving environments safely. Right? That is how it is done. So fourth point is sensor fusion, which actually integrating the multimodal sensor data for robust, redundant, and perception. Right? I do not have the Google form, Sheikh Hanif. It is XLR a tech person who will be sending it in some time. Just please wait and be patient about it. So training data is critical. ML models requires millions of labeled examples from diverse driving conditions, supplemented by simulation to cover rare edge cases and ensure safety. So that is very much important, right? Because your safety is very much needed in that sense. So your ML models require millions of labeled examples from diverse uh, driving conditions, which supplemented by simulations to cover rare edge cases and rare edge cases and ensure safety. Okay. So now comes the mapping and localization. So what is mapping and localization? Can you please tell me what is mapping and localization? Just a minute. Can you please think about it, ponder and tell me that what is the meaning of mapping and localization? You can just write in the chat if you want. Yeah, I think nobody has responded to it. So, yeah, so mapping and localization. So mapping and localization is nothing but actually creating a virtual space based on certain GPS and GNSS and SLAM and SD map technique, which actually helps you to build a environment to actually ease you in motion or moving from point A to point B without any hindrance. So it actually makes a complete environment, virtual environment, which is understandable by the system in such a manner that your decision making ability becomes simpler for the autonomous vehicle. So, mapping and localization. So, precise localization, knowing the vehicle's exact position with centimeter level accuracy is essential for safe path planning and navigation in complex environments. Okay, so that is true that mapping precisely localization, knowing the vehicle's exact position with centimeter level of accuracy. So that centimeter level accuracy is very much needed, right? So yes, so attendance system you can mark your attendance. So yeah, so mapping and localization. So precise localization, knowing the vehicle's exact position with centimeter level accuracy is essential for safe path planning and navigation in complex environments. So yeah, safely if you want to plan your paths and work in complex environmental conditions, so your mapping and localization becomes a very key parameter in actually operating the complete system in that manner. So that is very much needed to actually operate in that fashion. So that is the reason for that. Okay. So first point is SD maps. So high definition maps actually it provide lane level detail including geometry, road markings, traffic signs, and semantic attributes that go far beyond traditional GPS navigation maps. So yeah, HD maps are actually the high definition maps, which actually I told you right at the start of this class that this compute system is actually automated, and the automated system requires high level of systems that are available. So the best or the best systems that are available in the market, be it a camera, be it anything and everything, whatever is the best system that is available in the market, that is being used for the complete operational abilities of the autonomous vehicle because your complete decision making ability is being dependent on these sensors and the data collection that is happening from them. So, image processing and sensor data collection is the very much key parameter in actually attributing towards the completely decision making ability of the system. So, your HD maps are the high definition maps that provide lane level detail including geometry, road markings, traffic signs, and semantic attributes that go far beyond traditional GPS navigation maps. Okay. Second is the SLAM technology. So SLAM is nothing but SLAM is very much important. I would suggest you to go back home after this class, open Google and search about SLAM, watch some videos on YouTube because it is a very much demanded thing in today's world. If you are an electronics engineer, if you are a embedded software engineer, or if you are an AI engineer, you are aspiring to be an AI engineer. SLAM technology is very much important because this is something related to perception and GPS denied navigation. So yeah, SLAM technology is simultaneous localization mapping. So you localize the thing and parallelly simultaneously map the thing also. So that enables vehicles to build and update maps in real time while determining their position, crucial for operating in unmapped or changing environments, right? So when you are not having a mapped environment, you are working in a atmosphere or environment where your GPS is not working or your complete system is dynamically changing, your map is dynamically changing. At that point in time, you are uh, want to actually follow these in a very crucial mode, wherein your SLAM technology, simultaneous localization mapping, enables vehicles to build and update maps in real time while determining their position, crucial for operating in unmapped or changing conditions, so changing environments. So this is very much important, unmapped and changing environments. Okay. Third point is GNSS plus IMU fusion, which is Global Navigation Satellite System. So the GNSS is also an important thing, which is combined with inertial measurement units. It provides continuous positioning, sensor fusions, handle GNSS outages in tunnels or urban canals, ensuring uninterrupted localization. So this is the one. So GNSS is also important. So you go through this slide. Just let us take a break of 2 minutes and then we'll resume. Okay. So yeah, am I audible? Uh,
Yes, sir, you are
o-
audible.
okay. So yeah. Uh, yeah. So SD maps, SLAM technology, and GNSS IFS IMU fusion. So GNSS IMU fusion that we were discussing, the global navigation satellite systems combined with inertial measurement units provide provide continuous positioning. Sensor fusion handles DNS outages in tunnels or urban canyons, ensuring uninterrupted localization. Okay. Now comes the planning and control. So I think this would be the last slide that we'll be discussing today. Maybe in the next class we'll be discussing the rest of the things that are left. So I think after this there will be um, 3 more classes, I guess, 3 or 4 more classes, based on which we will be trying to complete. There are two PPTs, one, and after this one more is there. That is, this is the introduction of everything, autonomous vehicle, and that is the core flight mechanics that is involved in the autonomous vehicle or the aerial autonomous vehicle. So that is the second PPT. Once that is done, we will be in a position to address a few more challenging topics uh, involving the analysis. So we'll be now doing the second stage. We'll be doing the autonomous vehicles analysis, wherein we'll be taking topics related to that and solving that as well. So, yeah, let us see how we can take that into consideration and move forward. Uh, so, yeah, that is there. So, planning and control, the brains of autonomy. So, the autonomous driving system processes information through a hierarchical planning and control architecture operating at different frequencies for optimal decision making. So that is true that the autonomous vehicle system processes information through a hierarchical planning and control architecture operating at different frequencies. So different frequencies are there on which it is operating. The sensors of that complete system is operating for optimal decision making. So all these sensors actually we discussed right in the start of this complete system that so yeah, so the planning and control is actually uh, there. So the autonomous driving. So we discussed right at the very start that the complete system is actually built in such a fashion or such a manner that the system or hierarchical system is being negotiated or the complete sensors that are onboarded are being planned in such a coordinated fashion that each and every sensor's operation is actually complemented by the other sensor's operation, and the complete efficiency is being restored and maintained. So that is how the things work here. So the autonomous, so operating at different frequencies for optimal decision making. And that is resulting into optimal decision making. So route planning. So first one is the route planning that determines the optimal high level path from origin to destination, considering global map data and traffic conditions. So decision frequency is seconds to minutes. So this is actually the key thing that determining the optimal high level path planning. So there are two different stages of that. First is the global level, and the second one is the local level. So the global level is actually taking care of the higher order things that the path planning is correct and everything. And the local level is actually taking the global traffic information data and routes planning data, and then they both coordinate among themselves in a proper fashion, and that is resulting into a proper planned attitude, behavior, technique, which is making the which is making the autonomous vehicle to move in a linear path or in a designated path, whichever is required. So that is the case. Second is the behavior planning. So decides on practical maneuvers like lane changes, turns, and interactions with other road users, adapting to dynamic environments. So decision frequency at a seconds. Okay. Then is the trajectory generation that is creating a smooth collision-free paths for the vehicles to follow in the immediate future, updating continuously. So this is decision frequency in milliseconds. So the behavioral plan, so route planning is actually decision frequency seconds to minutes. Behavioral planning is decision frequency to seconds. Trajectory planning is the decision frequency to milliseconds. And low level control. So executes precise commands to the vehicles actuators, steering steering throttle brakes to accurately follow the planned trajectory. So here the decision frequency is in milliseconds. So that is the thing that the route planning is a higher order thing. So it takes around seconds to minutes. Variable planning is also a global level thing. So it is actually taking seconds. Now trajectory generation and low level control are actually the local level planning techniques. So these are actually operated in the milliseconds. So that is how we'll take this thing forward. Um, yeah, I think we'll take the rest of the things in the next class, maybe. So rest of the thing we'll take in the next class. And Yeah, so yeah, is it fine if I actually uh, drop the class? Host, can you please hear me?
Yeah, yes, sir. Thank you, sir. Thank you for such an informative and insightful sessions.
Yeah, thank you so much. Yeah.
Yeah. Dear student, please make sure to mark your attendance without fail. The attendance link will remain active till 9:30 p.m. only, so kindly complete it before that. Also, there will be no session on Monday due to the festival. We will meet in our next session on Tuesday. Dear students, kindly mark your attendance. We will meet in our next session on Tuesday. Those who marked your attendance, kindly drop a call.